Okay, so what we do is we put in our probability, which in this case is 0.95. We put in our mean, which is 22. We put in our standard deviation, which is 7.3. And it spits out the value 34.01, which is what's called the critical point. So this is 34.01, or 34. So the answer is we should have 34 chairs. I don't think we'll worry about the 0.01. Another example of this is in flying, is that lots of times people don't turn up for flights, and so all airlines, especially in the United States, overbook. And they go on the idea that they work on what's the probability of people not turning up for a flight, because they do not want empty planes, because that's wasting money, or not getting as much money as they would like. And depending on how cheeky they are and how much they don't care about their customers, they set a level of which they expect people not to turn up, so that if too many people turn up, they just get bumped. And people get offered money to be bumped, or accommodation, all sorts of deals. And some people actually manage to get lots of cheap flights by always turning up near the end, getting bumped, and then the airline gives them extra money to fly on a different later flight and things like that. But it is sensible, to a certain degree, to allow for that, because that way they're making the best use of their resources. Okay, now I've got two examples here about a lunchroom, and I want you to have a look at them and see if you can work out which one's going to use norm dist and which one's going to use norm inv. Right, well, I'm not going to thrash this horse any further. Why not make sure you never run out? We know why you should never run out is because that would be wasteful. So we'll just put that down to wasteful. Okay, so is this norm inv or norm dist? Hands up if you think norm inv. Good, that's correct. Okay, and we have the percentage, so norm inv. So it's told us this 10%. And we're going to find out what the number is. So we put in the mean equals 84, standard deviation equals 10.7. P, probability, is it going to be 0.1 or 0.9? And so those who think 0.9? You're correct, it's 0.9, good. Because Excel works upwards, okay? Well, downwards, I guess. It always goes to the left of wherever it is. So the P is 0.9. And so what we'd go is we go equals norm inv, open brackets, 0.9, 84, 10.7, and the answer will be 97.7. So what does that mean? It means you should order 98 rolls. Or maybe 96 would be better, because maybe they come in bags of 6. So at least we've got an idea of if we get that many rolls, then we're less likely to, well, we're only going to run out 10% of the time. Okay, so here daily takings are approximately normally distributed with a mean of 820 and a standard deviation 110. How often out of a term of 50 days would you expect to have takings over 1,000? So we want to know probability that takings is greater than 1,000. So that's going to be 1 minus the probability that takings is less than 1,000. Okay, and that's going to be equals 1 minus the norm dist, because we don't know our probability, that's what we're trying to find out. Our mean, our number of interest is 1,000, our mean is 820, our standard deviation is 520, where did that come from? 150. And is it true or false? True. For normal, it's always true. True, true, true. And so that gives us 0.1151. But that is not the answer to the question. And be careful, because people in proctored quizzes often go, oh yeah, there's my answer, I'll put it in. But they don't go, hang on a minute, what was the question? And it says, how often out of a term of 50 days would you expect to have takings over $1,000? So we then go 0.1151 times 50 equals 5.75. 5. So you would expect to take over $1,000 on 6 days out of the 50. Okay, if you can't read that, have a look online. The ones that all filled in will pop up. Well, have a lovely second semester. Try and keep up. And I'll see you about 2 weeks before the end of the semester.